Okay, College Algebra 2.3 is about functions. It's a relatively simple section, but let's get your mind warmed up for things to come. So general fact about functions, not every set of data is a function. A set of ordered pairs is called a relationship. It has an input and an output. And a function is a special relationship where each input there's exactly one output. So that means for every x value, there's exactly one y value, and it's not a function if you have the same x value going to two different y values. So determine the following are functions. C is 4, 5, 5, 7, 6, 1, and 2, 4. Is C a function? Well, do you see an x value repeating and going to a separate y value? You don't see that, so therefore, yes, it's a function. Because as far as we can tell, each input has exactly one output. Now, they can also be given to you in table form on your homework. Here's a set of x's and a set of y's. Does the table represent a function? You're really looking for repeating x values, and then you have to check, are they going to the same or different y values? Here 2 is going to -1, here 2 is going to -7. That means it's not a function because you have the same input going to two outputs. Different outputs. And the last kind of problem you might see is this kind of bubble, which represents the domain and range. Here, this means -1 is mapping to 2, following the arrow. 4 is mapping to 3. 6 is mapping to 2. Is it a function? Yes. Even though we have two different inputs going to the same output, that is not the same as the same input going to two different outputs. So this is a function. You can have two different inputs going to the same output. Now, with this kind of thing, we can also find the domain and range as well. So let's look at more. The domain is the collection of all x values. The range is a collection of all outputs or y values. For the domain, it can either be discrete, which usually when you have a collection of these points, it's discrete, but if it's like a function, you may have like an actual range and interval. So determine the following relations are functions and find the corresponding domain and range. So here, we see 7 going to 4, and 7 going to 3, so this is not a function. The domain, because it's discrete sets of points, you use braces, and you see all the x values. I'm going to put them in order, but it doesn't matter the order, so -2, 5, 7, and 9. Again, the order doesn't matter in here. I just like to go from least to greatest. The range, I see 1, 3, 4, and 6. Okay, now ways that you can be tricked. Looking at this table, 2, 4, 6, 2, -1, -1, -1, -1. Yes, we have a repeating x value, but both of those x's are going to the same y value, so this is a function. Just because you see two of the same x value doesn't mean it's not a function if they're going to the same place. Our domain, looks like we have 2, 4, and 6. And our range is just -1. Everything's going to -1 from what we can tell, which is a possibility. Okay, see, again, let's do a bubble. Say we have 4, 5, 7, and 11. Now, is this a function? No, because again, we have this 4 and it's mapping to 3 different outputs. But what's my domain? It's just 4. My range is 5, 7, and 11. This is how you do it from a set of points. What about from a graph? So for graphs, which you'll usually have a picture of, you use the vertical line test to determine if something is a function or not. And usually that means it'll either be graphed for you or you have to graph it. So let's talk about y equals x is a diagonal line through the origin. So what is the vertical line test? It's where if I drop a vertical line through any point on the graph, I should only be hitting the graph in one spot. If I ever hit it in more than one spot, it's not a function. That's the equivalent of one input going to two outputs. The vertical lines represent each input, and you can't be hitting two different outputs. Generally speaking, linears are, this is a function because it passes the vertical line test. The only linear function that doesn't pass the vertical line test is literally a vertical line. If we want to do the domain and range, the domain here is all the x values, so it goes all the way left and all the way right on the graph. That's represented by negative infinity to positive infinity. The range does the same thing from low to high, so this is negative infinity to positive infinity as well. X equals negative y squared, so most people know what y equals x squared looks like. X equals negative y squared, or x equals y squared in general, is the parabolas that either are right or left. In this case, it's going to the right. I mean, not the right, the left, because it's negative. I was drawing left, said right. So anyway, this is x equals negative y squared. Now you notice when you do the vertical line test here, what happens? We hit two different points, which means it is not a function. So what's my domain? Looks like all my x values are either at 0 or to the left. So we go from negative infinity to 0. 0 is included because 0 squared is 0. Range. My y values are going up and down, so it's negative infinity to positive infinity. And lastly, y equals x squared you may be more familiar with. It's the parabola that goes up and down. This actually does pass the vertical line test, which means it is a function. Its domain, it goes all the way left and right. It's kind of like the opposite of the x equals negative y squared up there. But its range is only from, because if you square a number, it's non-negative, from 0 to infinity. Okay, real quick. You won't see this much, but just in general, is an inequality a function? Well, remember, an inequality, this is really y is less than or equal to negative x plus 2. For an inequality, graph-wise, you graph the line, y equals negative x plus 2, which will look something like this. And then you have to shade a side of the graph. In this case, it's less than, so it's underneath. So that means if you draw the vertical line test, just by logic, not only do you hit more than one place, you're hitting this infinite amount down here. So generally, inequalities are not functions. There are a few exceptions. If your inequality is just a single point, like x squared plus y squared is less than or equal to 0, it is possible, but generally, it's not a function. We won't do a domain and range on this. Anyway, we will finish this section in the next video.